Thank you, Kurt. Good morning, everyone. I hope that everybody's awake. There's a coffee machine outside. If you're not awake, I suggest you go and grab some coffee. I had a triple espresso 5 minutes ago to try to wake up. So thank you for being here. What I would like to talk about today is innovation primarily, because innovation is the fuel that drives our community, it drives HPC. Without innovation, we cannot create the tools, the software, the systems, the solutions that enable our customers to create and to innovate. And so one of the questions I have is, what is going on with innovation in HPC? There have been a number of announcements in the last months or so, in the last couple of years or so. The industry is changing in a pretty fundamental way. And one of the concerns that we have, having been in the industry for many, many years, is, well, what is going to happen to innovation? Because as we all know, HPC is all about long-term investments. You invest in developing, creating, architecting technology. It takes years and years and years. You bring it to market. Customers are wonderful, but they say, no, we need a lot more capabilities, and we want it for free. And that's not how big companies in technology typically operate. Big companies are focused on the enterprise, and it's really driven by financial metrics and financial goals, not by R&D and engineering. And I was just looking the other day at, what is the R&D spend in some of these large organizations who are now, for the most part, driving the HPC elements inside of them. And the R&D spend is 5 to 6%. And then I said, well, how much do we spend? And it's like, God, we spend 16% of our revenue goes into R&D, as it should be. Of course, our CFO said, well, Alex, look, that's what we should be spending, right? Typical financial response. The good news is we are committed to HPC, we are committed to innovation, and our pledge is to continue to spend a lot of money in R&D to continue to develop technologies and solutions that are enabling for our HPC community. I think that today, more than ever, we need to invest in innovation, and we need to develop tools and capabilities which will help our customers make sense out of all the craziness that's going on. I mean, 5 years ago, 10 years ago, data centers were fairly simple. Everything was on-prem. People were building monolithic solutions. It was all about, fast interconnects, CPUs, slapping storage on top, making the end-to-end work. Now there is just a huge amount of complexity that's been added into the mix. And we need to make sense out of that complexity, and we need to architect solutions which streamline, which provide efficiency end-to-end to the applications in distributed environments, on-prem and in the cloud, multiple cloud mechanisms. New CPUs are coming into the fray. GPUs are more and more enabling. AI is coming into the mix as an enabler to HPC and data at scale. And making sense of all of this and architecting technologies that are enabling in this context is increasingly complex. And that means stepping up the investments. It doesn't mean stepping down the investment, which is what we're seeing in a number of areas. So again, our pledge is to continue to invest in order to help solve these challenges, which I believe are, on the one hand, far more complex than they used to be, but on the other hand, far more enabling if they are addressed properly. So, I mean, that kind of brings us to DDN. I mean, DDN has always been focused on HPC, big data, and now AI as an extension of it. I mean, we've been at it for 20 years. Paul and I, when we started this, we were, I think, 16 years old or something. So here we are 20 years later. So 20 years of commitment and innovation in HPC and in big data. And I think the proof point is the trust that our customers have put in us. I mean, we now have thousands of customers who have successfully deployed large-scale solutions, who are doing amazing things because we're developing at-scale solutions that help these things happen. One of the side effects is, lots of patents that we've developed and applied for and received in the field. So 140 patents. Again, it's HPC-centric, a lot of this thing. 10 exabytes of storage systems and solutions deployed into the field. We are present and are developing technologies not just in the context of data and storage, but also in the use cases. I mean, the use cases, whether it's in academia, the big labs, financial services, healthcare, oil and gas, these are all different. I mean, you could say, well, it's all data at scale, but there are nuances and subtleties that unless you get into the details and develop solutions and engineer solutions that are specifically designed to meet those requirements and excel at those requirements, it just won't be right for those customers. So we've been doing that for a number of years. And Intersect 360, I mean, Addison's here in the room somewhere, just published a report, and I think that is the validation. I mean, DDN is number one by far in terms of deployments, recognition, and the response from customers. So thanks to all of this, I guess, we are given an incentive to continue to serve our community, our HPC community, and continue to innovate in the field. Now, what does that mean? How do we see innovation, and what is it that we focus our R&D dollars on? It's really four areas. It's platforms, because without the right underlying hardware, without the right platform which scales, which is efficient, which has the right inside networking, the right processors, the right data management paths, you can't really do anything. So platforms is at the bottom of it. Then you have file systems on top of it. You know, file systems embedded into the platforms are enabling because they tie into the use cases and the applications. Then there's an open source component. I mean, there are many, many users of Lustre out there, and so supporting the open source community is very important, so we'll continue to do that. And then there's collaboration. It's sitting down with our customers and saying, okay, what are some really complex problems that need to be solved, and how do we collaborate with our customers to make that a reality? So these are kind of the four elements that we look at when we think of innovation and how to invest. So platforms. Platforms is a number of things. It's platforms at very large scale, so exascale computing. We are involved and have deployed some very large-scale solutions. And so it's ensuring, as we develop our underlying platforms, that these platforms continue to serve the needs of the community for the very, very large systems. Because from those very large systems, from the innovation and the R&D that goes into creating systems for very large applications, we can then derive the pieces that take it one notch down into the rest of HPC and big data. So large-scale systems are extremely important, and that's where a lot of innovation goes in terms of platforms. Then you take it one step down and you look at AI. In recent years, we've seen a significant growth in our AI business. I mean, frankly, to us, AI is HPC modified in some ways. It is an enabler, it is an accelerator to HPC, but taking the technology that we develop for very large-scale systems, we've put together solutions that are enabling to AI, and we'll kind of talk more about what those are, why they're differentiated, why they're creating a lot of value for our customers. And then flash, in terms of the various media elements that come into the fray, how to best utilize flash at the highest efficiency possible, not just as a piece of hardware, but actually delivering the IOPS and the capabilities that are needed in flash. So that's kind of the platform piece of it. Then you layer file systems on top of it. So really two things. Exa 5, which we're very, very excited about. I mean, last year we acquired the kind of Lustre division from Intel, took that, added lots of engineering resources to it, really stepped up the investments. And so we've been developing some really cool features and capabilities on top of Lustre, which James will talk about. And And I'm sure you will find those very appealing in the context of what a file system needs to do today and how it needs to behave in the future. So there are security attributes, reliability, obviously performance at scale, efficiency, and we'll be talking about those things. And then there's IME, which is kind of an SSD-centric cache-enabling piece of technology, which we started developing 5-6 years ago, have done lots and lots of deployments in the field, some at very, very large scale. And so that is the layer that gets applied on top of the platform and makes the platform really perform. And it's a combination of the two, which I think is very powerful. And so when you think in terms of innovation and investments in R&D, you have to invest in both pieces. I mean, the third element in that is the openness. So openness is in the context of the file system. So Lustre, obviously, continuing to support kind of the open source community. I mean, it's really interesting. 55,000 lines of code contributed into the latest version of Lustre, going back into the community. More than 5,000 systems open Lustre out there that we're supporting, enabling, and helping our customers with, and hundreds of customers who are using systems and solutions with the open source version of Lustre, which is a wonderful thing. Building and supporting systems for our partners. Again, we do not operate in a vacuum. We develop data-centric solutions. These solutions get deployed in larger systems which have a compute element, which have a networking element. And so a lot of what we do in the context of the end user requirements is working with our partners. So making sure that we continue to support our partners, that we qualify, we optimize with the various platforms and solutions that each one of our partners uses. A lot of expertise at the system level. I mentioned that a little bit earlier on in terms of, an at-scale system, an HPC system in financial services is very, very different from the same thing in academia or in life sciences. So, I mean, DDN, you look at the engineering and technical organization, we have roughly 500 people who are engineers, developers, and their job in life is to develop, architect, deploy, optimize in the field solutions that really deliver everything that is required in these at-scale requirements. So it's continuing to do that in a broad way, taking into account the idiosyncrasies and the specific requirements of each use case and each market. And then it's a product portfolio that is very open, that can be deployed in a variety of ways without vendor locking, that can connect and attach in the most efficient way possible into all of these environments that our customers are using. I mean, some of our customers are saying, well, let's architect the best solution possible. Some customers say, well, I have religion. I do this thing, and this is what I do. So DDN, help me optimize the solution in the context of this partner, this technology that I'm enamored with, and that I want you to work with. So we do all of the above. I think that has given us the privilege and the opportunity to become a trusted advisor to many of our customers at large scale and helping them solve their large scale problems. And then collaboration, it's really in the very specific context of extremely difficult problems to solve. And it's coming in and saying, well, you know, here's a problem we need to solve. For instance, autonomous driving at large scale. How do we architect a solution that solves the autonomous car problem at scale from the edge to the core all along? Very complex problem. That requires collaboration, and that requires tying in what we do into the applications, into what the end user or the partner are doing. So we have a number of those things underway. I mean, we've been doing it from the very, very beginning of DDN, when our first collaborations were with the Department of Energy in the US, at Lawrence Livermore and in other places, where it was, well, we are trying to hit performance requirements, price points, efficiency levels that are just not possible with current technologies. What do we need to do long-term collaboration to achieve these requirements. So that is something that we feel is extremely important, and it's a very HPC-centric way of looking at things. In the enterprise, nobody cares about that. It's okay, give me the solution that works, and I don't want you getting into the details of the technology because, frankly, that's not what we do. That's not what we understand. But we think this is very, very important. I would like to touch just a little bit on some of the things that we're developing in the future, because, again, you have short-term innovation and deliverables. Again, EXA 5, the IME file system, the various platforms, A3i for AI requirements, CSFA 18K with embedded file systems. But we're also developing new technologies, which we will bring to market in years to come. And so one of the problems which we feel is very, very important to solve, and we've invested a lot of R&D resources in the last several years in developing these solutions, is in the area of intelligent management of data in an omni-cloud type of deployment. And the reason I'm saying omni-cloud is because it's not really a multi-cloud. It's on-prem as well as public clouds. And it's wherever it should be, whenever it needs to be, at any point in time with flexibility. So it's really omni. It's all of it everywhere with full flexibility. So we've been developing, working in R&D on what we believe is an extremely powerful framework, which does two things. One, it delivers intelligence into data. So it looks at workflows, use cases, data patterns, analyzes it, redirects it, and automatically, seamlessly, without the customer having to get involved, provides the most efficient, cost-effective, safe, reliable way of handling data and handling content. And the second piece of it is a delivery mechanism, which is the cloud piece, the omni-cloud piece, which is, well, this should be handled on-prem, this should be handled with this particular public cloud provider, that should be handled with this other public cloud provider. And today it's like this, but tomorrow it might be completely different because the economics might change tomorrow based on whatever is going on with the public cloud providers and with whatever the budget requirements are and so on. So very excited about this. Say it starts like this somehow. It always starts with spaghetti mess, and then it kind of miraculously turns into products. I still haven't figured out how that happens. But it does happen somehow. So this was, I think, 3 years ago. It kind of looked like this, and now we're starting to see prototypes and really cool things happening in these technologies coming to life. And it's always very, very exciting to look at these long-term projects and saying, well, today we're investing in developing some technology, and 5 years from now, 6 years from now, that technology becomes a reality. Again, it's a long-term approach to innovation, which is what we love. I mean, that's why we are in HPC and in big data, because you get to do cool things over an extended period of time. So that's kind of the future. I would encourage all of you to come and talk to us if you want to find out more about what we're doing in the context of, at-scale, intelligent, omni-cloud types of technology. So come talk to us. I mean, some of you have kind of seen what these architectures are. I think some of you might have tested some of these things. But come talk to us. This, we feel, is extremely exciting. We think this is the future of HPC, AI, and big data. So that's all I have to say. And with that, I will give it to Dr. Coomer, who will prescribe whatever you need for any ailment you might have, including your data infrastructure.